So you end up having 2 to the power of x on the left and 2 to the power of 2 on the right. Now, since the base is now the same, it therefore means that the exponents are equal. So our x-intercept is going to be equal to 2. Now, we can write this as x is equal to 2 and y is 0 in coordinate form. Okay? In coordinate form, it becomes x equal to 2 and y is equal to 0. Now, in order to determine the y-intercept, okay? Are you following?
Yes, sir.
All right. In order to determine the y-intercept, you must substitute x equal to 0 into this equation. All right. So where there is x here, you put 0, and where there is x there, you put 0 there. So you end up getting that equation. Now we need to solve for y. So this becomes f0 is equal to, do you mind if you can maybe turn off your mic so that we can communicate via chat, because there is interference going on. Hello?
Yes, sir. We'll do that.
Okay. We'll communicate via the chat option. So I want you to pay attention very, very carefully for question 7.22. Now, because an exponential function has only one asymptote, okay, it means we are only supposed to write one equation. And an exponential function has a horizontal asymptote, which is given by that plus q. That q in the general equation is the one which determines the value of y along the horizontal asymptote. Now, your horizontal asymptote, it must be written as y equal to whatever the value of q, you put it there. Okay? So all you have to do is identify the q value in the equation. When you write it down, it must be written like that. Okay? So for our question, our q is a 4. It's that value. It's a positive 4. So where there is q here, I'm going to put 4 so that the equation of the asymptote becomes y equal to 4. You don't write asymptote equal to, no. Okay? So let's move on to the next page. So for 7.22, the equation of the asymptote is y equal to 4. That's the equation. Alright? Okay? So let's move on to 7.23. Write down the range of f. Write down the range of f. Now, it's very important for you to know that for an exponential function, if you want to know the range, you must use your value at the horizontal asymptote. Okay? Now, because we have this minus, that minus there, in front of that 2 to the power of x, it means that our graph is going to be below the x-axis. It means that our graph is going to be below this minus here. It indicates to you that the graph is going to be below the horizontal asymptote. If there was no minus here, it means the graph will be above the horizontal asymptote. So it's very important for you to know that when it comes to an exponential function. Okay? Now, if you go back to our question, okay, we are going to be moving to and fro. Now, the range, okay, the range is the set of y values. Okay, remember, the range is a set of y values. So, this word range means we want the y values. Now, if you go back to the graph, Okay? If you go back to the graph, you find that the limit of the graph in terms of the maximum value of y is going to be the value of y along the horizontal asymptote. Okay? So the largest value of y is going to be that one. Okay, at this point here. And here, y is equal to 4. And the equation of the asymptote is y equal to 4. But because y equal to 4 is an asymptote, it means that this curve, this curve, this whole curve, it will never touch y equal to 4. Okay? It will never touch y equal to 4. So the limit of the graph in terms of the maximum value of y is going to be 4. The minimum is going to be negative infinity there. So for the y values, they can never be equal to 4. Okay? But they can approach 4 because we have a horizontal asymptote. Now, what that means is when we are writing the range, okay, when you're writing the range, we write it as the following. We write our range as, we can write as minus infinity is less than y. Now, because the curve will never touch the asymptote, but it's going to approach it. Y can never be 4. So we can write, but y is less than 4. That's one way in terms of notation. Or you can write this as y is an element of real numbers, but y is less than 4. That's another notation. So we are saying y can never be 4, but it can be close to 4. Okay, and y can take on all the real numbers, but those real numbers must be less than 4. Okay? It says write down the equation of g of x if g is the reflection of f in the x-axis. Alright? Now, for you to be able to understand it, okay, it's better for you to have a visual of the sketch of the graph of f first, which we have. So we want the equation of a new graph called g of x, such that it is a reflection uh, of of what? Of f about the x-axis. So let's go back to our graph. Now, this is our graph. Okay, if we are to reflect this graph along, or rather about the x-axis, it means that from your previous knowledge, if a value of x was positive, okay, it's going to remain what? Positive. All right? If a value of y was negative, it's going to change from being negative to positive. So it's only the y values that are going to change in terms of their sign, that is being positive or negative. But the x values keep their signs. Okay, so when you look at it, you find that if I were to reflect this graph about the x-axis, it's going to be like this. You are going to end up with, we've got f of x equal to minus 2 to the power x plus 4. So what's going to happen is g of x is going to be equal to minus f of x. This, this minus here, it represents a reflection about the x-axis. Okay? If reflection takes place above the x-axis, it's only the y value which changes its sign. The x value remains the same. That's very, very important for you to know. So, all we have to do is substitute f of x, which is that. So we end up having minus, open bracket, minus 2x plus 4. Now, I want you to be aware this minus here is related to that minus. That's the minus which represents a reflection about the x-axis. Now it's very important for you to know that. Then this minus here is the minus of the equation. That is the constant in front of that 2 to the power of x. Okay? Then when we simplify this, we are going to get g of x equal to 2 to the power of x minus 4. Now, do you see that the value of y at the asymptote was positive 4? Okay? Now it's going to be negative 4. So if we reflect the graph about the x-axis, okay, the asymptote also moves. Okay, it will move to be under the x-axis. That's why this becomes your new equation. That's the equation for g of x. So if you reflect a graph about, in this case, the exponential function about x-axis, the asymptote moves from being above x-axis to below or vice versa, depending on where it was located initially. And also, if your graph was a decreasing function like that, okay, this is called a decreasing function. Okay, if you reflect about the x-axis, it will now become an increasing function. Okay, so let me just show you the graph itself. So this is your answer for uh, for uh, the equation for g of x. But I just want to show you now. So if I were to call g of x, okay, let's go there. So 7.2.4, your answer will be g of x is equal to 2 to the power of x minus 4. Okay, now let's sketch that so that we can analyze it. Now I'm just gonna call it h of x because of this g here. I hope you can understand. I have got a g already, y equal to 4 based on the software. It's called the equation of the asymptote g. So I'm going to introduce h, but need to know that that h is our x, is our g on the equation that we are dealing with. So it will be 2 to the power of x, right, minus 4. All right, just okay. I need to look at it now. So our new y-intercept, okay. So our y equation of asymptote will be y equal to minus 4. That will be the equation. So let me just indicate this one here. Let's make it bold. Okay. So we'll make it. Okay. Let's not change the color. We can make it thicker. Okay. We can make it thicker, and then I also need to make the asymptote thicker. So let me, okay, the color I'll keep it, the style make it thicker, and that. Okay, so this is the scenario now. Okay, that's what you have there. So this graph, this one here, okay, that one, uh, this graph is the one that you get. This is what's going to be g of x